Now let's put all the pieces together to add and subtract rational expressions with unlike denominators. And we'll do the same steps that we did for fractions. Find a least common denominator, write the expressions with the new denominator, and then add or subtract the numerators, making sure if we're subtracting we distribute that negative sign into the second rational numerator, and then we simplify. So in our first example for adding and subtracting rational expressions with unlike denominators, we have the first denominator a squared minus 10a plus 24. Let's begin by factoring this quadratic polynomial. A in this case is just a variable, so we take the first coefficient 1 times 24. We get 24 to multiply. And our middle number, negative 10, being multiplied by the a, we need to be able to add to negative 10. So two numbers that multiply to be 24 and add to be negative 10. A few seconds to think about it, and you'll come up with negative 6 times negative 4, which will add to be negative 10. So we take this middle term, negative 10a, and we break it apart. Negative 6a minus 4a plus 24. Group them. And factor out the common factors. And we end up with a minus 6 times a minus 4. Noticing in the second rational expression, we have a minus 6. Our least common denominator will consist of everything in the first denominator, a minus 6, a minus 4. And then we check against the second denominator. Do I already have a minus 6 represented in my LCD expression? I do, so I do not need to write it again. To get that second denominator to have the same form as the LCD, we don't get to just write a minus 4 down there and we're done. We've changed the problem fundamentally now. It's not the same problem. But what we are allowed to do is multiply by a special form of 1. So I want a minus 4 to show up in the denominator. I'm going to multiply that second rational expression by a special form of 1, a minus 4 divided by a minus 4. I'm only changing the look of the problem. I'm not changing the actual problem itself. And then the next step, 3a plus 2, a minus 6, a minus 4, minus, now I can distribute 2a minus 8, distribute the 2 times a minus 4 to get 2a minus 8, and then a minus 6, a minus 4. And then in the next step, making sure that I notice this is subtraction, and I need to distribute that negative sign to all of my numerator parts in the second rational expression, noticing that my denominators are now identical. I'm going to combine my numerators. 3a plus 2 minus 2a plus 8, because of this minus times a minus, we'll end up with a plus. And now we can combine like terms. 3a minus 2a is a, 2 plus 8 is 10, a minus 6, a minus 4 on the bottom, and we cannot cancel anything out. A plus 10 does not cancel with anything on the bottom, and that would be our final answer, a plus 10 divided by a minus 6 times a minus 4. Looking at another example, we can play the same game with 5 over m squared minus 9m plus 8 minus 3 over m squared minus 6m minus 16. We need to factor both of these denominators into their factor pairs and then be able to create our least common denominator from that. I'll leave this one for you to think about. See if you can come up with it, and then check your answers on our class 1 note when you get a chance. But I will come down here to number 15 because of how different it can be in the way that it's structured. Here, notice we have a difference of cubes in the denominator on the first fraction. So difference of cubes, we have to remember the pattern of the factoring. So the first thing I'm going to do is figure out what is being cubed in each of those terms. So 27 is 3 cubed. 8x cubed, 8 is 2 cubed. And so then I can write out my factors. First, second, first squared, first times second, second squared, and then I can input my signs. Same as what's given, opposite, always positive. And then my numerator 5x on top. And now I'm going to add on to that 1 divided by 4x squared plus 6x plus 9. And notice I have that factor in my first denominator as well. So our least common denominator will take all of the first denominator, 2x minus 3, 4x squared plus 6x plus 9. And then we compare to the second one. Do I already have the factor of the second one in my LCD? And I do. So I do not need to copy it again. Now, first denominator already has the LCD. Second denominator does not, but we can make it so that it has the least common denominator by multiplying by a special form of 1. I'm missing 2x minus 3 in my denominator, so I'm going to multiply top and bottom by 2x minus 3 in that second rational expression. Now my denominators match, and I can combine the numerators. 5x plus 2x minus 3, 2x minus 3, 4x squared plus 6x plus 9. Simplifying the numerators, 7x minus 3, 2x minus 3, 4x squared plus 6x plus 9. I cannot factor the numerator any further. In the denominator, the quadratic that occurs, it actually is not factorable, so I cannot simplify that one any further. And that, my friends, is our answer. So when working these adding and subtracting rational expressions with unlike denominators, we want to follow the same patterns that we were doing with fractions, but now with polynomials, we just need to make sure we're paying attention to detail, watching our signs, and following through on the steps.